Hi, now we are learning about quadratic function. So quadratic function is polynomial function where the highest power of an independent variable x is 2. So here we can see that three types of quadratic function. No real roots, one root or two equal root, and two real roots. In this video, I want to teach you on how to use GDC to analyze your graph. So the first thing you're going to do to make sure your graph fits your window. So you're going to use zoom fit here. Next, you can go to the analyze graph and here we're going to want to find the maximum point. So there you go. Next, you're going to find the real roots by analyzing graph and press 0. Since we have two real roots here, so you need to do it twice. And there you go. You have it now. Inverse function is quadratic function that is reflected on when y equal to x. So in only have one-to-one function, and if we have many-to-one function, it is with restricted domain. Here we have the movement of function, and in this note you have type of movement, and you can see the graph and the formula that have. So you can pause this video to see the notes better.
This is 6.2 transformation of graphs. So the transformation of functions can be expressed in three different ways, which is the description of the movements, the shape of the graphs, and in the way of formulas. So we have an example of y equals to a function which is x squared. And if we see the first graph here, the graph is shifted to the right, from the red to the green one. And we see that there is a horizontal translation of k units to the right. And so the formula will be written as x minus k in brackets squared. And vice versa will happen if the graph is shifted to the left. It will be a horizontal translation of k units to the left, and the formula will be written as x plus k in brackets squared. So that will happen if it shifts to the left. And for the second transformation is when the original graph is shifted upwards, there will be a vertical translation of k units upwards. And so the formula will be written as x squared plus k. And if the graph is shifted downwards, there will be a vertical translation of k units downwards. And so the formula will be written as x squared minus k. Okay, for the third graph, you can see that the original graph becomes wider. It is stretched wider, and so the description for it is a horizontal stretch of scale factor of k. So the formula is written as 1 over k multiplied by x in brackets squared.
Okay, moving on to vertical stretch. So vertical stretch happens when x squared, or the graph, is multiplied by a scalar factor of k. So this will cause the value of the graph to increase more faster. So this will cause the graph to become more narrow. Moving on to vertical reflection. So vertical reflection of the x-axis only happens when a negative sign is introduced outside of the parentheses of the graph. So this will cause a reflection on the x-axis. Moving on to horizontal reflection on the y-axis. This is when a negative sign is introduced inside the parentheses of the graph. So this will cause a reflection on the y-axis. So there you have it for 6.2.
Cubic functions. Cubic functions are a polynomial function with the highest power of x is 3. It has at most 3 roots, meaning that it intersects the x-axis at most 3 points for at least 1 point. Unlike quadratic functions, not all cubic functions will have a local maximum or minimum point. From the first graph on the left, you can see that it has a local maximum point and a local minimum point. However, on the graph on the right, it does not have any local maximum or minimum points. To model a cubic graph, you need at least 4 points. A cubic graph has a point of inflection. A point of inflection is a point where the cubic graph has rotational symmetry and where the function changes concavity from a upward concave to a downward concave or vice versa.
Power function. The power of function could be classified into two. So there is a table to differentiate even power and odd power. A variation also has two, which is direct and inverse. It is really important for us to differentiate them. And then this is how on the graph of even power and odd power look like. It is very important for us to know about the graph too. And then lastly, exponential function. So the function is a power of x plus b, and b is the horizontal asymptote. All exponential graph has horizontal asymptote. So the example is below, which is exponent graph is shown with horizontal asymptote y equals to 0.
Here are some tips when using the GDC for this particular chapter. So imagine if you want to restrict your graph to a certain domain. So here is the way. First of all, watching this graph 2x cubed minus 2x squared minus x plus 3. So press Ctrl and equal to. You can choose this symbol and now you can enter your domain like always. So take this one, which is the less than or equal to sign, put x in the middle, and in this case I want to see the graph between 0 and 2. So enter, and you will get the shape of the graph between 0 to 2. There are also some tips where you can find the corresponding value of y just by entering the value of x, and that's by chase. Press menu, chase, and now you can pick any number in this graph to find the corresponding value of y. For instance, if I want to choose 1.75, press enter, and I can get the value of y for 1.75 will be 5.84. So you can use these tips when using the GDC to answer this particular chapter. Thank you.